Hello and welcome to today's math lesson. So we are talking about polygons in yesterday's lesson. And so if we look at these polygons, if you look at them, they are all quadrilaterals, but one of them is just a little bit different than the other one. Which one is that? Yep, this one. This one's just a little off. Whoops, two T's. This one's a little off. This one is a trapezoid. Does anybody know what the other ones are all called? The yellow, the red, purple, orange, green. What are all of the other figures called? And the other figures are all called parallelograms. So today we're going to be studying a specific quadrilateral, and it is going to be the parallelogram. So what is the definition of a parallelogram? And the definition of a parallelogram is, first of all, it is a quadrilateral. So it has to be a quadrilateral, four-sided figure with both pair of opposite sides parallel. So it is a quadrilateral with both pair of opposite sides parallel. So this top side is going to be parallel to the bottom side, and the left side is parallel to the right side. So now, what kind of properties are a parallelogram going to have? Well, the first one is just the definition is if a quadrilateral is a parallelogram, then, so the definition here, both pair of opposite sides parallel. All right, so what would happen is I would give you a parallelogram and we would be doing an investigation in the classroom if you were here. So if you guys look at these, what do you think is going to happen if you measure this top side and you measure this bottom side? What do you think perhaps is going to happen? And then if you measure this left side and this right side, what happens is both pair of opposite sides are congruent. Okay, so that is something that happens every time you have a parallelogram, is that not only are opposite sides parallel, but the both pair of opposite sides are congruent. All right, so now let's look at this next one here. And if I could give you a protractor and have you measure this angle and this angle, what do you think's happening? Well, let's go and do maybe another one here. Is because this top side is parallel to this side, and then so this side is parallel to this side, and now this one is a transversal. What did we review yesterday about parallel lines? And then what did we find out about this angle and this angle? We called them consecutive interiors. Okay, and so what happens here is this angle and this angle are consecutive interiors. So consecutive interior angles are supplementary. Now, it doesn't matter which ones you take, because if you took this side parallel to this side and this was the transversal, isn't this angle going to be supplementary to that angle? So it doesn't matter which one you take. So now it also would work if, let's just put numbers in here, 2, 3, and 4. If 1 and 2 are supplementary and 2 and 3 are supplementary, They're 1 and 3 are supplementary to the same angle, so 1 and 3 must be congruent. And the same thing happens with 2 and 4. So this blue angle and this blue angle are going to be congruent, and the two red angles are going to be congruent. So both pair of opposite angles are congruent. All right, so both pair of opposite sides are congruent, both pair of opposite sides parallel, both pair of opposite angles congruent, and consecutive angles are supplementary. All right, there's one more thing. So if you look at this diagonal, this green diagonal, and we look at this purple diagonal, are they congruent? And I sure hope you come up with the answer of no, because that green diagonal definitely looks smaller than the purple diagonal. So they're definitely not congruent. If we look at them, this angle and this angle, yes, they're a linear pair, so they're supplementary, but they're not equal to each other, so they're not perpendicular. So what else could be happening? What do you think would happen if we measured the length of this, and then we measured the length of this right here? Is the green diagonal cutting that purple diagonal in half? Well, what do you think's happening? Is the purple diagonal cutting the green diagonal in half? So what we have here for our last theorem is going to be that the diagonals bisect each other. Okay, they're not necessarily perpendicular to each other, but the diagonals bisect each other. All right, so here are all of the theorems written in a nice organized form. It's exactly what we just did. If a quadrilateral is a parallelogram, then opposite sides congruent. If a quadrilateral is a parallelogram, opposite angles are congruent. If we have a parallelogram, then consecutive angles are supplementary, and then the diagonals bisect each other. So if you need to, you can certainly pause the video and write down what you need to. All right, so now using some of that stuff, what is the length of FH? Well, FH is running right into a diagonal, and so what do we know? FJ is going to be congruent to JH. So 4Z minus 9 must be equal to 2Z. 4Z minus 9 equals 2Z. So 2Z equals 9. So Z must be equal to 4.5. All right, so now how long is FH? Well, if you find out one of them, if we find out JH, let's take 2 times 4.5 is 9, and then double it. We're going to get 18, and there's no label, so it looks like we're going to have units in there. So 4Z minus 9 equals 2Z. Subtract 2Z, add 9. Z is 4.5. All right, so we get 9 and double it to get 18. All right, the three vertices of the parallelogram are P, Q, R, S. So P, -3, 1, 2, 3, 1, 2. Looks like this is P. Q is going to be -1, 1, 2, 3, 4. S, 1, 2, 3, 4, 5, 0. Okay, where can R go? So where does the vertex of R go? The big tricker here is that some people like to go, let's see, what do we do? 1, 2, 3, 4, 5, 6 over 2. 1, 2, 3, 4, 5, 6. And then, whoops, 1, 2, 3, 4, 5, 6. And then over 2. Actually, it would be this way. Right here. Okay, so is this R? So let's look. PQRS, PQSR, is that in the same order? And it is not in the same order, so R cannot go there. So R has to be over in this vicinity over here. So that was up 6 and over 2. 1, 2, 3, 4, 5, 6 and over 2. So it's going to have to be 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to count up 1, 2, 3, 4, 5, 6, and then over 2. So R, what the heck? I'm on my eraser. So it has to be over here so that we have the same slope, so that this side is parallel to this side. And now this side slopes will end up being parallel to that. So R has to be over here. So please make sure that when they say PQRS, you do not put those letters out of order. All right, I think that brings us to the end. So in your homework, they're going to mainly be asking you questions to find out things like this. So like in here, I could have told you, okay, this is 130 degrees. So now what's the measure of angle H? So that is 130 degrees. Now, what do we know about the measure of this whole angle E, FEH? That's going to have to be 50 degrees because they are supplementary. All right, so everything is going to tie back to opposite sides congruent, opposite angles, consecutive angles, and the diagonals bisecting each other. Good luck on your homework.